Welcome to the Explainer. Today, we're looking at something that honestly affects every single one of us, yet it happens completely invisibly, right up until the very moment it's too late. I'm talking about the invisible forces, the massive amounts of energy and moisture quietly, secretly building up in our atmosphere. It's literally a ticking clock of extreme weather. And let me tell you, when that clock strikes zero, the consequences are incredibly violent. So let's dive into this and see exactly how nature's most devastating forces are built, triggered, and mathematically tracked.
Section 1. The Sudden Strike.
You know, what makes extreme weather truly terrifying isn't just its raw power. It's the element of surprise. Often, these events strike right after a long dry season. The earth is parched. The landscape seems entirely peaceful, right? But above that peaceful landscape, a massive hydrological engine is churning. So what happens when the sky can no longer hold its weight? The atmosphere above us is quite literally holding oceans of water. When it finally lets go over a landscape that just cannot absorb it, the result is absolute catastrophe.
The answer to that question is 10 meters per second. Think about that for a second. That is the sheer speed flash floods can reach when heavy rainfall hits dry, mountainous areas. The parched earth just can't absorb the sudden deluge, so the water pools and then violently rushes down into the valleys. At 10 meters per second, this water becomes a lethal force. It's instantly sweeping away vehicles, massive rocks, and carving a path of absolute destruction in just a matter of minutes. No warning, just devastation.
But these sudden disasters don't just magically appear out of nowhere, right? They are born from extreme atmospheric tension. Long before a single drop of rain ever hits the ground, these incredibly complex physical processes are warring with each other, high above our heads.
Which brings us to Section 2, Anatomy of a Storm.
Think of the hydrological cycle like an incredibly complex bomb just waiting to detonate. Let's walk through this escalating countdown together. Step 1. Warm air, totally loaded with water vapor, rises and expands. And as it goes up, the pressure drops, which leads to a temperature decrease, averaging about 0.65 Kelvin for every 100 meters. Okay, step 2. As that air cools, it physically loses its capacity to hold on to that vapor. Then, step 3. This is the critical moment. The excess water violently condenses onto microscopic aerosols. And finally, step 4. When those droplets become just way too heavy, gravity takes over. They plummet to the earth. But what actually lights the fuse? Well, there are 5 main catalysts for this atmospheric uplift. You've got convection, which is purely driven by heat energy. Then fronts, where wet air violently clashes with cold, dry air. Orography, which is where mountains physically force moist air upwards. Convergence, mostly happening in the tropical zones. And lastly, the ultimate atmospheric monsters, cyclones.
Section 3. Awakening the Dead City.
Okay, we've looked up at the massive storm clouds. Now let's go all the way down into the microscopic, invisible world waiting beneath the dry soil right before a storm hits. A million bacteria in a single gram of dry soil. During a long drought, these vast numbers of organisms lose their activity completely. It is, literally, an invisible, dead city lying silently beneath our feet, just waiting for a trigger. And the exact second that 10 meter per second flash flood hits this dirt, it triggers a sudden, violent revival. The dead city resurrects instantly. The bacteria wake up and immediately launch into massive nitrogen production. This instant fertilization sparks a frantic rush of life. Seeds germinate, roots fiercely carve out new subterranean roads, and insects furiously build. The violent storm from above actually creates an absolute explosion of life below.
Section 4. Monsters of the Sea.
Now, zooming rapidly back out from that microscopic dirt, we have to face the most terrifying macro threat on the planet. When that atmospheric uplift we talked about happens over warm ocean waters, we get cyclones. Take Hurricane Katrina from August 2005. The deep red ring right in the center of the storm is the glowing eye wall, completely surrounded by relentless rain bands. It is a literal bullseye of destruction. This isn't just a storm. It is a massive, self-sustaining engine of atmospheric violence. And here's exactly why they're so incredibly dangerous. The cyclone threat multipliers. Because they're born over warm ocean water, they act like giant, unstoppable vacuums. They continuously absorb massive amounts of moisture and heat energy. So unlike a quick-passing thunderstorm, they use this endless ocean fuel to unleash high-intensity rainfall for incredibly extended durations. They just sit there, spinning and dumping water, completely overwhelming any landscape they touch.
Section 5.
calculating the threat.
So, with storms getting this massive, how do we even prepare? Well, scientists have to look at historical data to predict exactly when these extreme weather monsters will return. Say we're looking at a 10-year record of annual maximum daily rainfall. The very first rank could be a terrifying daily rainfall event of 70 millimeters. By crunching the math, hydrologists determine its probability of exceedance is 0.09, and that translates to a return period of 11 years. It's mathematical tracking, laying out exactly what we are up against.
This is the very essence of frequency analysis, calculating the exact probability that a devastating event will strike next year, or say in the next 10 years. You can kind of think of the return period as a mathematical countdown to the next inevitable disaster. It's the average time in years between occurrences. The clock is always, always ticking. But actually tracking the beast? It is incredibly difficult. Scientists generally use two methods, and truthfully, both have flaws. The annual maximum series tracks only the single highest peak flow of the year. It's really easy to process, but what if a year has two massive, catastrophic storms? The second one gets completely ignored. The alternative is peaks over threshold. This captures every single event that crosses a specific danger line. But defining that exact threshold is incredibly tricky. A slight miscalculation, and you severely underestimate the incoming threat.
So here we are. We know the physics. We know how the air rises, cools, and violently condenses. We know how flash floods tear across parched earth at 10 meters per second, waking dormant cities of bacteria. And we have the statistical countdowns telling us that the oceanic monsters will inevitably return. The mathematical clock is ticking, folks. So the only question left for you to ponder is, are you prepared for the 100-year storm?